All right, today we're putting on our detective hats. We're going on a digital manhunt, you could say, tracking down a fugitive that every single developer, well, dreads: the vanishing user request. Okay, so let's get right into it. You click a submit button on an app. To you, it probably feels like it happens in a flash, right? But what's really going on behind the scenes is this incredibly complex, hidden journey. We're going to follow one of those requests and see just how deep this rabbit hole really goes. Yeah, you can really think of it like this giant, invisible maze. That single click has to navigate through dozens, maybe even hundreds, of interconnected services. And you know what happens when things go wrong in a maze like that? When a request just disappears or fails? Well, finding the why can feel completely impossible. So, to make this a little more real, let's set up a digital mystery. Imagine this. You run a financial app, and the most important thing a user can do, submitting a loan application, is failing. But here's the kicker. It's only failing sometimes. Users are getting errors, but it's intermittent. It's like you've got a ghost in the machine. I mean, this is the exact scenario that keeps engineering teams up at night, right? The user's obviously frustrated. Your support team is just getting flooded with tickets. And your engineers, they're flying completely blind, trying to find a needle in a digital haystack. The stakes are just massive. Every single minute of downtime is costing you real money, and more importantly, your users' trust. And the worst part? The system is a total black box. So this all boils down to one central question for the team. Where in the world did that user's request go wrong? And to solve this, you can't just look at one piece of the puzzle. Nope, you have to become a true digital detective and follow the entire trail of evidence, all the way from that first click to that final frustrating error message. And this is where our investigation really begins. We're going to follow what's known as the golden path. Now, what's that? Well, just think of it as the perfect, ideal, successful journey that a request is supposed to take. If we can map out that perfect path, we can start to spot exactly where our failing requests are going off the rails. So for our loan application mystery, the investigation is going to follow a pretty clear chronological path. It all starts in the user's browser, right? From there, it hits an API gateway. Then it gets bounced around a few microservices. Maybe it takes a detour through a message queue. And finally, it tries to write to the database. The key is we have to check for clues at every single one of these stops. Okay, so that's the path, but how do we actually collect the clues? What are these digital fingerprints we need to look for? Because we can't just guess, right? We need cold, hard evidence. Well, that evidence has a name. It's called telemetry. I like to think of it as the digital exhaust. You know, the trail of fingerprints left behind by our request as it zips through the system. And for our investigation, we're going to focus on collecting three main types of these fingerprints. First up, we've got metrics. Honestly, the best way to think about these is like the system's vital signs. You know, its heartbeat, its blood pressure. They give you that high-level, is everything okay view. Stuff like CPU usage, memory, request rates, error rates. Are error rates suddenly spiking? Is the CPU just pegged at 100%? Metrics give us that crucial big picture. Okay, next on our list, logs. So if metrics are the vital signs, then logs are like the detailed, moment-by-moment diary of events. They're the eyewitness accounts written down by the services themselves. A log can tell us, hey, user X just started their application, or validation was successful. And most importantly, it can scream, error, connection timed out. This is where we get the specific details. And last but definitely not least, we have traces. And let me tell you, these are the real game changer. A trace is basically a GPS map for our request. It shows us the entire path it took, connecting all the different services. It even tells us how much time it spent at each stop along the way. This is our map of the entire crime scene, from start to finish. All right, so we've got our metrics, our logs, and our traces. We have all these clues. But now comes the aha moment. How do we actually connect all these dots to solve the mystery? And here is the massive challenge, right? In any busy system, you're looking at millions of logs, tons of metrics, all pouring in from dozens of systems every single minute. It's just an overwhelming flood of noise. So how on earth do you find the handful of clues from one specific user's failed request in all of that chaos? The answer, my friends, is something called a correlation ID. This is the master clue. It's like the unique case file number for our investigation. It's a special, unique identifier that gets attached to a request the second it's created. And then it travels with that request through every single service, tagging every log, every metric, every trace it creates along the way. And this right here just perfectly illustrates the difference it makes. Before you have a correlation ID, it's just chaos, a massive jumbled mess of disconnected log entries. It's impossible to follow one user's journey. But after, with that ID, you can just filter everything, and suddenly you have a complete ordered story of one user's request from start to finish. The mystery just unravels. So, back to our loan application case. The team searches for that user's specific correlation ID. And what do they find? The story tells itself. The request got through the gateway just fine, it passed the validation service, but then the logs for the credit check service show a connection timeout. Bam! The culprit wasn't their code at all. It was a partner's API that was failing on and off. Mystery solved. So now that we've seen how this detective work plays out, the big question is, how can you use this observability blueprint in your own systems? How can you solve these problems before they turn into full-blown crises? Well, here's a pretty straightforward action plan you can follow. First, you've got to identify your golden path. What's the most critical journey for your users? Step 2, instrument every single step of that path. Make sure you're collecting that telemetry. Step 3, and this is the big one, generate a correlation ID right at the very beginning. Step 4 is to make sure that ID gets propagated everywhere. And finally, step 5, use that ID to tie all your metrics, logs, and traces together. You know, the really crucial point here is that great observability isn't just about showing you that something is broken, it's about telling you the story of why it broke. This whole process, it's not just about collecting more data. It's about turning that mountain of data into a coherent narrative. It literally transforms your system from this opaque black box that you're always reacting to into something you can actually have a dialogue with, especially during an incident. So, I'll just leave you with this one question to think about. What's the most important golden path in your system that right now you just can't see from end to end? What's your biggest block box? Because figuring that out, that's the very first step to solving your next big mystery before it even has a chance to begin.